Welcome, this is Geometry B, Unit 4 sample work. If you've been doing the sample work all along, I applaud you because that's the way this is designed to be done. When you go through a lesson, as you see the keywords for the lesson, write down the keywords, write the definitions, and provide a sketched example. One way to do this is to do it all on notebook paper, writing everything out. That's the way I'm going to do it here, writing it on my screen. Another way is to use Word or another word processing document program to create the words and the definitions and then print that out and sketch the examples on that. A third way is to do an image search and copy and paste an image for each. I find it's actually faster to do the sketches. With that in mind here, if you want to follow along while I do the assignment here, this is sample work unit 4. First word is Pythagorean triple. Pythagorean triple. Pythagorean. I always like how that sounds. It sounds strange. Now I'm writing sounds. Pythagorean theorem. Pythagoras was a Greek mathematician about 550 BC, founded a school of philosophy and mathematics. The Greeks combined philosophy with mathematics, and many of the great mathematicians in history are philosophers. But not Pythagorean theorem, Pythagorean triple. Triple. Okay. 3 whole numbers that satisfy the Pythagorean theorem. Which is a squared plus b squared equals c squared. Example, 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. So the 3, 4, 5 triangle is a Pythagorean triple. Okay. 2. Okay. Primitive Pythagorean triple. Okay, a Pythagorean triple in which all 3 numbers are relatively prime. That means nothing divides all 3 evenly. An example of what it is not: 6, 8, 10. Which is a multiple of 3, 4, 5 times 2, because they all divide by 2. So divide by 2, that becomes a 3, 4, 5, which is a primitive Pythagorean triple. 6, 8, 10 is a Pythagorean triple, but it is not a primitive Pythagorean triple. So all 3 numbers cannot be divided evenly by the same number. Okay, next word, angle of elevation. Okay, 3. Angle of elevation, also called the angle of inclination. Elevation. Angle of elevation. The angle of looking up. So if we got a guy down here looking up at a bird, right, the angle of elevation is the angle between the horizontal and the angle he's looking at. Call it theta. That's the angle of elevation. Angle of elevation. Also called the angle of inclination. Okay. And then we've got the angle of depression. Forgot the word of. Depression. I don't mean getting sad. Also, angle of declination. The angle of looking down. Someone goes to the Grand Canyon. Looks down at the river. The angle at which between that and the horizontal is the angle of declination, or the angle of depression. Angle of looking down. Number 5. Inverse function. It's a function that switches input and output. For example, f of x equals x plus 2. F inverse of x equals x minus 2. That's because if I put in 2, 2 plus 2 is 4. If I put in 4, 4 minus 2 is 2. It ends up right back where we started. It undoes. Okay? Another way to say is function of undoing. Inverse function. 6. Inverse sine. Also known as arc sine. Takes a ratio and gives an angle. If this is 3 and this is 4 and this is x, then sine x equals 3/4, or arc sine, sine with a little negative 1, of 3/4 equals x. Inverse sine. Inverse cosine. Also called arc cosine. Takes a ratio, and I should say the ratio for inverse sine is opposite over hypotenuse. A ratio adjacent over hypotenuse, and gives an angle. In this case, if this side is 2 and this side is 4, then it's going to take cosine of x is 2 over 4. X equals arc cosine of 2/4. Eight. Inverse tangent. Also called arctan. Takes a ratio. In this case, opposite over adjacent, and gives an angle. Example, if I know the opposite and the adjacent, so I know 3 and 4, then tan x equals 4/3. X equals arctan, or inverse tan, 4/3. Okay. Number 9. Law of sines. The ratio of sine to the opposite side is constant. That is, it's a formula. Sine A over A equals sine B over B equals sine C over C. Give you a case of angle side. If I know this is 40 degrees and I know this is 60 degrees and I know this side is 8 inches, then we would say sine, and I want to know this side is x, I would say sine of 40 is to 8 as sine of 60 is to x, and I can solve that for x. Number 10. Law of cosines. This is simply a formula. A squared equals b squared plus c squared minus 2bc cosine A. I like to think of it as the side squared equals the other two sides squared and added minus 2 times the product of the other two sides times the cosine of the angle between them. The good case where we might use that is in side angle side. Let's say this is 8 inches and this is 9 inches and this is 40 degrees, and I want to find x. X squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times cosine of the angle between them, 40 degrees. Okay. Now there's a second version of the law of cosines that looks like this. Arc cosine of b squared plus c squared minus a squared over 2bc is capital A. You might use that in a case where you know all the sides. Let's say this is 8 inches, this is 9 inches, this is 10 inches, and this is x. Then arc cosine, or I should say x equals arc cosine of the adjacent sides, 8 squared plus 9 squared, minus the opposite side, 10 squared, divided by 2 times the adjacent sides, 8 times 9, is x. Okay. The law of cosines was pretty involved. And number 11, oblique triangle. I've been using the term non-right triangle. So no 90-degree angles. Okay. Example. You could have a triangle with 40 degrees, 80 degrees, 40 and 80 is 120, and 60 degrees. Okay. None of them are right angles. All right, that's it.